fully to run a command. The exploit, the reason why you see the code being printed in so many different lines is because there's a restriction on the length. So simply what you have to do is, once you already know what's the entire code that you want to run, you basically push it in different statements. And this is just, again, another example of a command execution vulnerability, which doesn't rely on anything regarding memory corruption bugs. It's a Firefox extension. Some of you might have heard it. It's called Firebug. It's very useful if you're into development or even security. It's basically a debugger, you know, for your browser. And in this case, again, it was vulnerable to a command execution vulnerability. So this is what's happening nowadays, you know. You go online, you have your browser, and we load our browsers with so much stuff, you know, so many extensions, plugins, you know. If only one of those components are vulnerable, basically your system can be compromised by simply visiting a page, you know. So it's one of those challenges that we have to deal with as users, you know. We all like installing random stuff, but, you know, we don't really know how secure it is what we're installing. So I personally like going online with restricted privileges if I'm on a Windows box, so just don't use an account that has administrator privilege. So if you get exploited, you will at least mitigate the consequence, you know, the privilege that the code is able to run as. This vulnerability was very, very, very interesting from my point of view. It shows that sometimes when you find something, you think that it's less serious than it is. I think it was in the full disclosure mailing list. Miroslav, I'm sorry if I mispronounce his name, Miroslav Lusinskic, sorry, I probably mispronounced it. He sent an email to one of the most popular, you know, one of the popular security mailing lists, and he said, look, guys, I realized I found something. You know, there's a cross-scripting in the Skype client, right? It turns out that Skype would allow users to share videos. So imagine you're chatting with your girlfriend, right? You say, hey, check out this Daily Motion video, you know, and then Skype would dynamically include the video clip on the window of Skype and a description and title of the video clip, right? So it's quite cool stuff, you know, from a user perspective, because it makes the Skype experience more fun. So this researcher, he noticed that in one of the fields of the Daily Motion video, right? So say that you upload a video, right? One of the fields that you can enter, I don't remember if it was the title or the description, but one of them allowed JavaScript. So this guy said, guys, there's a cross-scripting. Well, actually, this is not being run within the context of Daily Motion. This is not cross-scripting. As Aviv Rav pointed out, it's a local context or cross-context scripting. That means that this is the main idea, right? You find a vulnerability on a website. In theory, the code that you inject there should be logged to that domain. So it should be run within the sandbox of that domain, which means that that code should not have local access to your system. But because Skype is actually using the Internet Explorer engine in local zone, that means that now the JavaScript has full access to your system. So here, if you notice in the code, we're actually using WScript shell. With this ActiveX, you can run any commands, and there's no warning being shown. So how would you exploit this? Of course, it's been fixed now, but how would someone exploit this Skype vulnerability? Well, you know, create a video that says, I don't know, naked Britney Spears, put your malicious JavaScript. People will search for Britney Spears, click on it. You know, if it's being shared on Skype, it's command execution. Or perhaps the attacker is sharing the link directly on Skype. Remember that Skype will, or would back then, dynamically insert the different fields of the video, of the video that's being shared with the other user. So again, command execution, that's why PDP says that, you know, this presentation is about finding serious bugs without even trying, you know. And also, as PDP pointed out, if the attacker is in your same network, right, in the same wireless network, because as many public tools like Karma demonstrate, it's possible to to reply before the legitimate server replies. So the malicious video could also be inserted by someone in your same network. Of course, the assumption is that the attacker is sharing the same wireless as you. But it's another vector that has to be mentioned, when you're evaluating how bad a vulnerability is and what are the different ways someone would exploit it. Command fixation attacks. Okay, so there's a pro argument, there's an argument against this sort of attacks. Some people will claim, well, if you can trick me to double click on a file, then why not just send an executable to the attacker? Now, we are going to discuss a few different configuration files used by Windows Terminal Services, remote desktop, right? And also Citrix. There are several reasons why you might want to perform command injection by sharing a malicious connectivity file. First of all, a lot of these files, they're text-based, and their extensions are not being filtered by mail gateways. So it's much more likely than a file with the RDP extension will go through a mail filter as opposed to a file with .exe or BAT extension. So what these vulnerabilities basically, these attacks show is that it's possible to perform command execution after the user has performed a remote connection to a system. In this case, it's using RDP, right? So the idea is, the commands will be executed right after the user logs in. And this is, it's just an example of a possible social engineering email in which someone is sharing an RDP file and asking, take a look, try the file, and let me know if RDP is working, because we've been having some technical difficulties. So as you can see, there's some social engineering involved, but these files will definitely most likely go through the corporate mail filters. So everything is going over the web, so including remote desktop technology. So what's really interesting from right now, now that a lot of people are switching to doing everything online, sharing documents online, if whenever all of us are connecting to our desktops remotely, these vulnerabilities will have quite serious implications, because from our personal experience, anything that's over the web is quite trivially exploitable. HTTP requests can be forged. There's a lot of opportunities for attacks. So it'd be quite interesting to look in the future. 5 years when everyone is logging to the desktop remotely and their workstations have actually become dummy computers. Just like back in the days. When you had the heavy-duty server and then everyone would connect to it with thin clients. Now we're just doing the same thing again. We're putting everything on a server, The only difference is the server, it's on the internet. Anyone can connect to it. And this is the equivalent in the world of Citrix. Now, in the case of Citrix, it really depends on the configuration. But if you're using Citrix neighborhood and certain configuration is enabled, again, if you open this connectivity file or configuration file, it's possible to run commands after you log in. And what's really important here is that these commands are not now restricted to your local machine. These commands are being run after the user logs in. So if the victim user has remotely connected to their corporate network, the commands that are being run, the malicious code, could probe any service that should not be otherwise visible from the internet, because the assumption is that you have a secure remote connection. So that's just something, it's important to know that this malicious code would be able to probe any system that would be available in the Citrix neighborhood. And this was quite cool. I mean, back when, quite a few months ago, when there was all these issues being discussed about URL handler vulnerabilities, and you have Microsoft blaming the vendors, and the vendors blaming Microsoft. Is the operating system fault? No, it's actually your fault because you're sanitizing that parameter. PDP found quite a cool way to basically, make the Second Life client authenticate to a third-party site. Now the password is sent as a hash, but it's vulnerable to replay attacks. So you have two options. One, you crack the hash. If the password is weak enough, you'll be able to crack it with rainbow tables. Or, who cares? You don't have to crack the password. You can replay it, so you can still log in by forging the request to the server. And remember that there's a lot of trading in the world of virtual communities like Second Life. People sell their accounts for money because there's literally people that do this as a job, So it's quite interesting, stealing a Second Life account, it could have certain value in the market depending on, how much experience that user has gained through his user account. So now it's interesting because there will be, alternative ways, new ways for criminals to make money, It's not only about phishing your banking credentials. Now it's also about, just stealing anything that can be sold in the market, like a Second Life account, It's got a value, it will be sold, And this is, actually, if you look at the HTTP request, and you observe you look between the string tag, that's where the actual hash of the password is sent. That's just for you to know, what it will look like on the wire. Now, if we all like researching a lot of different types of vulnerabilities, but if you stay in touch with reality, we still find two common attacks which lead to most users being compromised or money being stolen. One of them is phishing, and the second one is drive-by download attacks. If you want to read more about drive-by download attacks, Wikipedia has an excellent page. And a drive-by download attack is nothing else than tricking the user to open a file, I mean, I have people in my family whose laptops keep getting compromised, and the truth is that some of these guys, they're really good at faking web pages to make it look like it's the actual operating system. So they will show a web page which looks like Windows XP telling you to update your antivirus. So a non-technical user has really no ways to know whether or not it's the desktop that's telling the user to do something or a website. With this unbuilt-in script, you can create a Java applet with a customized field. So the browser will show a warning because the applet has not been signed. It's not properly signed. But there's a lot of companies connecting to their own websites where they're required to run an applet, and the applet has not been signed. So the idea behind this script, if you're doing a penetration test, which combines a bit of social engineering, right? You could use this script to create your customized applet and with your own customized fields. So ideally what you want to do is make it look like the fields actually match the company name that the victim works for, the website name. So it's a little tool that you could use during your penetration test assessment. And this is, that's again, we're running a command. Of course, remember that the user must be tricked to run the applet, but at the end of the day, if the user is tricked, again, we have a command execution. This was the more recent QuickTime vulnerability that was published on GNU Citizen. What's cool about it is that it was cross-platform. It would work on any version of XP. And again, if you actually look at the source code, we're playing with different formats that are supported by the QuickTime plugin. Playing with the parameter in order to trick it to run commands, right? However, in this case, it was not so easy to run commands. If you look at the file URL, this points to evil.lnk, right? That's just a shortcut file. But the problem is that the Java virtual machine wouldn't actually understand that. It won't actually run the code that you're pointing to. So if you have the shortcut file, you edit it, and you make it point to an executable, the Java virtual machine will simply not understand this file type. It'll just do nothing with it. However, if you change the file URL to NetBIOS notation, the Java virtual machine will happily allow you to run the jar file, which ultimately leads to command execution because you can run any commands within a jar file. And this is, if you wanted to replicate this, all you do simply is modify a regular shortcut file